So I thought I would distract the engineers here with some fun facts. And one of the things that I'm particularly interested in and really made a study of is very large technology disruptions. One fascinating thing about technology disruptions is that most of the very largest companies that exist, almost all of them, with rare exception, were themselves the beneficiaries of seizing early on a technology disruption. And that's certainly true across the oil and the internal combustion engine industries. There are other mechanisms of making a very large company, and that's generally consolidation and so on. But the companies that go from really zero to almost monopoly status in a market, almost all of them started by seizing early on a technology disruption. And then they almost always happened within the lifetime of one person. And they almost always occurred within 20 or 30 years. And having achieved that level of dominance, it was very, very difficult to create a large company to compete. And it's not so very rare that a large incumbent actually shoots itself in the foot by launching the very technology disruption that kills it. A tech disruption results from a new way to serve and excite customers, which renders the massive economies of scale in an old technology obsolete. So in the internal combustion engine industry at the moment, if you're not huge, you can't make the product cheap enough to sell. But a new way of serving customers that doesn't rely on that economy of scale, that can bring in a product better and cheaper, is infinitely dangerous to a large incumbent of that nature. So, most famously, Eastman Kodak. Eastman Kodak developed the digital imaging chip, and which eventually went on to kill it. But the fascinating thing about that is it wasn't one company that took the digital imaging chip and killed Kodak. Lots and lots of companies that were not themselves really disruptive caused the customers of Kodak to simply ignore the idea of buying film and processing services. Then there's the example of GM, the GM EV1. Now, the government in California forced GM effectively, to launch a disruptive technology product. And they knew it, and they didn't want it. They really didn't want that badly. But they launched it anyway. They managed to kill it, and Chevron bought the patents to the Shinsky nickel-metal-hydride battery and shelved it. Now, but what you perhaps don't know, even if you are an engineer, is that it was ExxonMobil, that invented the lithium battery. Huh. Invented it in the 1970s, and it was a lithium-titanium disulfide battery. It was the first. It was a metal anode, lithium metal anode, and an extremely expensive and strange cathode. It was impossible to produce. But they invented it anyway, and they patented the lithium battery with a patent that expired in the year 2000. And it's since then that we've seen mobile phones and all the rest. That technology was shelved. But not long after that, it was an engineer in Germany that invented what they call intercalation of lithium ions in a carbon matrix. And what that does is it allows lithium ions to move in and out of really a massive network of tiny pores on the surface of carbon. And that made the battery, the lithium-ion battery, effectively rechargeable for the first time. And not long after that, a guy called James Goodenough in Oxford, UK, invented the lithium cobalt oxide anode. I'll talk about anodes and cathodes.
And just to clarify on the timeline, this is not long after Exxon patented.
This is not long after at all. This is within 3 years.
And what years are those? Like
around about 1970.
Okay.
So the lithium cobalt oxide anode. I need to explain that. If you have something like this, a hydrocarbon, you can pretty much call that an anode. If you have something like this, you can pretty much call it a cathode. So what a battery has in it is a combination actually of something that does the job of one of these things. This combination is not rechargeable, obviously. And that chain can get bigger and bigger and bigger until it becomes gasoline. But so the importance of the lithium cobalt oxide anode was that it was stable, at least in dry air, and it made it possible to actually produce a battery commercially. So a few developments later, through Sony and so on, there came a battery which was possible to put in a cell phone. And so, and of course from there we have the mass quantities of cell phones, and quite conveniently for this talk, we've had a pretty major revelation from Tesla with the Model 3. And so with that, we have an example of something that allows us to ask a better question. Really, a better question that's really ever been asked before about electric vehicles. And so this is really what I want to talk to you about, which is like an exploration of first principles about the following question. So why exactly is a battery just a cheaper and better and more advanced way of making a car? There's a departure from the normal mean that a battery car is expensive, but it has some benefits. One of the great pleasures of building battery companies in Malaysia is you get to live in the culture for a while. And one of my pleasures was to visit a Buddhist temple. And there's a piece of wisdom from Buddhism that got stuck in my head, which is to say, true wisdom is the appreciation of the unity of all things, and to appreciate the ebb and flow of things that appear to be fixed and unmoving. So, to pick up on that principle, what I want to try to do here is to build some kind of unified theory of transportation based on the redox reaction, the reduction oxidation reaction that occurs like this, and also inside a battery. It's found inside a production vehicle of any kind. If you exclude things, certainly a production vehicle of any kind. I mean, you can exclude odd examples like a Mars rover with a plutonium battery. And I want to explain it when talking about the ebb and flow, why the battery fits into the ebb and flow of large technology disruptions in a very ordinary way. There's nothing new about what is about to happen. If you think, just briefly, if you think about a mountain, you look at a mountain, or you know, an oil and icy industry. Here's one with a ski slope on it. You can look at that mountain and say it's always been there. It seems to have always been there, probably always will be. But the study of geology is to understand how it came up from plate tectonics and how it will erode away in the future. Then you understand a mountain in a way that just seeing it as a thing that's always there, it doesn't tell you anything. And the same very, very much applies to this. It rose extremely quickly in the era of Rockefeller, United States. The company started with kerosene oil in around about 1870s. And then with the advent of the internal combustion engine, that company took off in the space of 20 or 30 years and became a monopoly, a almost complete monopoly in the United States on the oil industry, with effects all around the world. Until eventually it was broken up. The same goes for the invention of the telephone. AT&T, Bell Labs, sorry, the Bell Telephone Company started with the invention of the telephone, became a complete monopoly, got split into Bell Labs and AT&T. So before going into the presumption of the cheaper and better way to make a car, it's probably worth checking that axiom directly. The basic premise of whether the Tesla Model 3 really is cheaper and better than a gasoline car. And this relates very directly to the questions about batteries. Because we talk about, is a battery good because it's got better energy density, or is it good because it's got better power density, or is it better because it's got better cost per kilowatt hour? But the truth of the matter is, any of these things are multivariate to be good. There's no such thing. Very often, it's often been said that there's no greater source of deception than the marketing of batteries. I think that was said by Edison. Quotes to exactly that effect. So, if we pick an arbitrary axis with positive here, and not so positive there, what sort of traits would mark out a better and cheaper vehicle? So, if you'll forgive me, bearing in mind we're in Germany, pick the BMW 328i as a comparison. And the reason I would do that is because the acceleration performance of the BMW 328i is identical to the announced figures for the base model Tesla Model 3. It's 5.8 seconds for the BMW 328i. So, what kind of metrics would make sense for a comparison between cars? Well, you can say, aesthetics, external aesthetics, acceleration, interior volume, handling, cabin sophistication, ability to charge at home, or what I would say is charge passively, ability to charge in the field, cost to charge in the field, and that could also be considered time spent at work. Lifetime mileage, probable. Smoothness, emissions. We can throw in maybe Autobahn. And energy cost per mile. I mean, go on and on and on like this. Smart grid. Compatibility.
Autonomous tech. Autonomous tech. You believe it?
Robotics.
Robotics.
So if we take the BMW 328i, we can say as a baseline, Yeah, it looks pretty good. The acceleration is pretty good. The interior volume, it's okay. Handling, excellent. Cabin sophistication, okay. Ability to charge passively, doesn't exist. You can't let it charge while you do something else. They'll arrest you if you try. Ability to charge in the field, excellent. Cost to charge in the field, well, if that's the positive access, not very good. Lifetime mileage possible. Let's say 20 years, 15,000 miles a year, 300,000 miles. Smoothness, it's okay. Emissions, okay. Autobahn capability, it's good. Energy cost per mile, not so cool. Smart grid compatibility, 0. Robotics, it's vaguely possible to make an autonomous internal combustion engine vehicle, but it's actually pointless. It's actually pointless, and I'm going to explain why. Once autonomy is possible with an electric vehicle, when you get rid of the cost of a taxi driver, basically, what you expose is the energy cost per mile and the amortization per mile of the vehicle. So if your vehicle costs, let's say, $40,000 to build, American terminology, sorry, but $40,000 to build, and you have a very long lifetime usage out of that, let's say almost 1 million miles, possible, nothing to stop that happening. And your energy cost per mile is extremely low. And that's all she wrote, apart from insurance and financing costs. Now, there's also the question of maintenance, which is also low. And in the case of a business like Tesla, it has access to the ability to field charge its vehicles in-house and service in-house. Right? They're both cost items. No one's treating those things as a profit center. If you then expose the same thing with an internal combustion engine vehicle, you're still left with the cost of the fuel and the maintenance and the depreciation of the value over a much shorter number of miles. If it's going to die at 300,000 miles if you drive it privately, believe me, it's going to die after 300,000 miles when other people are going around town. So what you end up is a compression of the amortization cost per mile by ×3. You end up with fuel costs probably ×3 or 4. Maintenance costs ×2, 4 maybe. And you end up with a proposition that doesn't matter what you do, once that technology appears, the internal combustion engine simply cannot compete, because what you end up with is a cost per mile for that EV, the actual cost of running it, with the finance, with everything bundled in, works it out at about 6 US cents per mile, all in. 100% profit on that service at 12 cents per mile. That's the cost of buying gasoline at $1.80, a cost at which the oil industry is going bust at the edges. Right? The layoffs, stock price going down. Right? Oil fields can't explore. Right? There's nothing left over to build an autonomous internal combustion engine vehicle. There's nothing left over for amortization. You can't amortize, there's nothing left, because this will wipe you out. And as a matter of fact, because this business of robotics, because you can take robotic controls all the way down to the powertrain, Right? There's no cut-off point where the electronics is trying to control mechanisms. You go right down to the actual ability to drive the wheels. Mine is a drive, mine is like a simple gear. You can make an effectively robotic, you can make a robotic vehicle. You can't do it with an internal combustion engine vehicle. If you can, but it's pointless. You just let the genie out of the bag completely, out of the bottle completely. It's game over. So when we talk about Uber buying 500,000 autonomous vehicles, there's no point. They can't add any value to it. You know, the ability to get on an OTA network and call a car to you and get billed over the air for your mileage. If the guy's done PayPal, probably okay. He's also an investor in Stripe, and that's the billing service behind Lyft at the moment, which is another San Francisco ride-sharing company. And Uber, I don't want to get off the track, but Uber was last valued about $50 or $60 billion, and it's valued at that sort of money because it's perceived to be a way of taking value out of the internal combustion engine industry without investing much capital to do it. So it's like many software companies of all kinds. The value they're not actually delivering any value that contributes to housing, food, transportation, or energy. The value comes from diminishing the real economy by adding efficiencies, which is a great thing. And so goes the same, theoretically the same with Uber, but it's not, in my opinion, true. What I believe Uber really is a labour exchange. It's a casual labour exchange with a bring your own device, except it happens to be a car. And once you remove the labour exchange from Uber, it doesn't exist anymore. That's it. So coming back to the Model 3, external aesthetics, better or worse than the BMW 328? What do you think?
Better.
It's not far off. Maybe a little bit better. Something like this, something like this.
Another colour.
Another, thank you. So, I mean, I don't mind being fair about it. Well, it's the same. What the hell have I written here? Acceleration. It's the same. Interior volume. It's better. Handling. Probably the same. Cabin sophistication. Infinitely better. Ability to charge passively. Infinitely better.
But just back to the acceleration too. I mean, the acceleration, I would say, is much better.
I mean,
because
there's a premise here.
Because the initial
35k. BMW 328i is about 36.7k in the United States. It's different here, I know. There's different taxation and so on, different local conditions. But this is what I know. So in the United States, 36.7 United States dollars. You can actually buy it for. So this takes out the differences in the business model. You apparently can't negotiate that price, but this is the after negotiation price of the BMW 328i average. What people actually pay for the car, having taken advantage of the dealership model whereby you can haggle 5 to 7% of the car. So cabin sophistication, obviously infinitely better. Ability to charge passively. This drives me nuts. People say that it's an advantage to go to a gas station and spend money you spend time at work earning. It doesn't make any sense at all. The ability to charge, to fuel an internal combustion engine car rapidly only addresses the problem of not being able to charge it at home. It's the main point of being able to do that. Because if it took much longer, bearing in mind it interrupts there's only one way to fuel a car. It's either take 1.5. You can either take a special journey to go and fuel the car, or you have to interrupt your journey at random. To do that, or planned, you have to stop a journey. You don't have to stop a journey with an electric vehicle necessarily, unless you're going past a certain range. So the fast fueling is addressing a problem of fossil fuels. It's not an advantage that electric vehicles have to overcome. Added to which, it's a nonsense to say it saves time, because most people have to work for the money to go and pay in the gas station. And if you look at United States figures from memory, it's cost the average American, I could be slightly wrong about this, but it's not far out, about 3 hours a week to pay for going to the gas station in order to save 10 to 15 minutes on the occasional journey in an electric vehicle. It's not an advantage. There are special cases where it's only, if you're a travelling salesman and moving on is much more important than the savings on your job, then so be it. But on average, it's a marketing nonsense. And it comes from the that kind of nonsense is propagated by the kind of people that will buy a battery patent and shelve it for 30 years. Ability to charge in the field, very high. So, what have I put here? BMW, ability to charge in the field, it exists. And interestingly enough, that will go down over time. For the Model 3, I suspect the average filling time will be more in the order of 10 minutes than 20. But we'll just say that it's not as good. It's half as good, let's say, a bit less than half. Cost to charge. Cost to charge. What the hell are we doing? Oh, tangent. So the cost to charge, it's very good. Lifetime, not completely good, it's very good. Lifetime mileage, very good. Smoothness, very good. Emissions, very good. Autobahn capability, not quite so good. But it's not bad either. Oh, really? I mean, if you can travel 200 kilometres, you're probably on the margins of whether it's okay, whether it's better to take a plane anyway. But I know here, in particular, this is a particular use case. It doesn't really exist elsewhere in the world. The tradition of driving a great distance at high speed. This is work in progress for electric vehicles. But coming back to horses, if I get time to do it, the horse was killed, or at least the use of it was killed by things like the Ford Model T. And there are certain things that horses can do that the Model T could not. For example, jump a fence. Or self-replicate in a field. But on balance, those things were not particularly useful compared with owning a car. But let me just... Smart grid compatibility, non-existent, great. Robotics, flipping fantastic, and utterly pointless in the case of the BMW 3. Except someone might think it's pointful enough to try it for a while until it goes away. Here's what I want to talk about regards this comparison between the Model 3 and the BMW. Just an example of an internal combustion engine car. The area, what matters in a value judgment, in my opinion, probably everybody else's too, is the area under the chart. So we have here two little instances that can justify a preference for a BMW 328i for an extra $1,000 or so. And that is the ability to charge in the field faster, as long as you're willing to pay for it, and ignore the fact you have to earn the money. So basically, if you're driving a car for someone that you don't care about and they're paying the bill, not bad. Autobahn use, which is a special case for Germany. But in Germany and in everywhere else, all this value, you get at a discount. You get at a discount for buying the Model 3. And that's just awesome.
And I would really put acceleration higher for the Model 3 because you have that instant torque, which is just one of the huge...
Yeah,
I mean,
but you don't need to push it. That's the whole point. You don't have to push this argument. It's just true. Even if you're kind to the other guys.
Extremely kind.
You get, this is not a GM Bolt. Right? The GM Bolt it's a PR exercise that is belonging to an ICE company that absolutely knows, and has proven it knows, that this is a disruptive technology that can kill it. And so what you have in a GM Bolt, and I of course, for my daughter and for electric vehicles are absolutely vital, but that's not the way to do it. The GM Bolt is built on the Sonic platform. It's pretty much, as far as a value proposition like this is concerned, it's pretty much the same thing as buying a $17,500 GM Sonic with better fuel economy, lower emissions, and a compromise to convenience. On balance, I'd say it's worth $17,500 for a GM Bolt. But they want to charge a $20,000 premium for an optional EV drivetrain. And at $145 per kilowatt hour of capacity in that battery, about $8,900 all in. Minus the cost of the engine, the fuel tank, the exhaust pipe, the starter motor, the battery for the starter, minus everything, there's absolutely no way that the GM Bolt costs $20,000 or anything like it more to make than the GM Sonic, nor does it provide any better value for money. That and that together, there's a disruptive tipping point. That's the real difference there. And if the GM Bolt was charged, was priced at $17,500, then GM would be in a lot of trouble. Because the disruption occurs not when somebody has got enormous scale in a new technology, but when the customer can comparison shop between the two options. And that happens, obviously in the case of Tesla, it happens before the product is even built. If you can comparison shop and go, you know what, that one's better for value for money, it really doesn't matter that the new technology doesn't have any capacity behind it, production capacity behind it. All that matters is that the consumer abandons the old technology and puts demand pressure on the new one. And if GM did that to itself, it would simply inform its own customers in its own communication channel that it's time to abandon the internal combustion engine, which is what keeps GM's lights on. And there's absolutely no way that at maximum about 5% profit per year that they can afford to tell millions of their customers that it's time to stop this and start queuing up for something completely different. Can't do that to themselves. It's absolutely impossible. It's absolutely impossible. There's no way around the economics without first going bust and starting all over again at whatever scale you imagine. Absolutely no way. German industry, this kind of matters. It kind of matters a lot. There is no win for trying to delay a transition like this. Once the disruptive technology is out there, you either are one of the first to grab it, or you're not. Now, some people talk about displacement of internal combustion engine cars with EVs. So if one EV is produced, the customer chooses the EV and not the internal combustion, and then the quantity of internal combustion engine vehicles goes down. But that simply isn't true. What it will do instead is take an internal combustion engine vehicle and move it to the used market. The new vehicle from the production line will still arrive, but it'll be harder to sell it. It'll be harder to sell it for the same money. It will put downward margin pressure on the ability to make internal combustion engine cars. And it will also start to worry consumers about residual values of internal combustion engine vehicles. So let's say Tesla or others in the same field, if they arrive, put 1 million cars onto the market. You end up with 1 million more used cars, suppressing the residual value of ICE vehicles. You worry the customers that the value of your car is not going to hold, and instead of buying the car from GM or BMW or any of them, instead of buying that car, they will demand to lease it, to transfer the risk to the manufacturer of what happens after 3 or 5 years of using that car. And that is the basis, in my opinion, a highly considered opinion, that is the basis of a subprime leasing bubble, like the subprime mortgage bubble that we had in 2007-2008. So what the internal combustion engine industry will do, in my opinion, and I think it's correct, is to continue to maintain production at exactly the same level and try to push it if they can, and accommodate customers that would prefer leasing. So for example, if you want a Model 3, you get on the list, maybe your car's a bit old, so maybe you lease one while you wait. And there is already the mortgage bubble that burst was visible in advance by a few people. And the leasing of vehicles is an uptrend. Now, it's already an uptrend, and I think that may even be in anticipation of this, to some extent, probably a large extent. So, if you're an investor, let's say it's in your pension fund or something, that you're an investor in one of these supposedly blue chip, too big to fail companies, it will look fine, and it will look fine, and let's say you're a lender as well. It will look fine, but the numbers will come out. They're more leasing than they used to be, but they'll come out and they'll come out. And then the vehicles will come back and the resale market won't stand them. And the companies will go precipitously bust. That, I believe, is a much nearer term future and a much more realistic picture than the idea that one EV replaces the mileage of one internal combustion engine vehicle. And even the idea of that, for example, the Tesla Model S customers, most of them can afford and might even enjoy the luxury of not selling their used internal combustion engine vehicle. They would give the impression that, look, I'm using this car more than that car, so the mileage is going down and it's good for the world, it's all great. But in the mid-market, people can't afford to garage and keep cars that they're not using. And this is the entire premise of Uber, that you've got this spare asset sitting there and it needs to be in the market. Well, of course it needs to be in the market. If you've got a car you're not using, you sell it. So that would be my prediction of how this will go. So they'll not say thank you very much for 100 years of good times. and pay out their creditors and issue a final dividend check, turn the lights off and say good night. It would go just like the mortgage bubble and burn the lot of them. And it would be relatively isolated in that industry, and of course have an immediate knock-on effect for the oil industry. What's happening now in America and elsewhere, Europe and Canada, is that to maintain the residual values of cars, there is, for example, just to Nigeria alone, $5 billion of used cars, mostly used cars, going to Nigeria to pull the supply of used vehicles out of the established markets. It's really, really fascinating stuff. So, you wanted to hear about batteries.
I think you're good going on whatever you think is interesting to give more perspective, more context.
What is just as incredible here about whether the Tesla Model 3 is competitive with internal combustion engine vehicles or not is provided by a site called Edmunds.com that produces estimates of total cost of ownership, 5-year total cost of ownership. So here we have a Toyota Corolla, BMW 328i. As we said, new price 36.7, let's say. Toyota Corolla. Actually, Edmunds have their own number. So, oh dear, 37.516. I'm not looking at that. 18,282. Tesla Model 3 base 35k dead. Apparently they're going to make it 34,999.99 or something in Washington DC because there's a tax break for that. Another story. Toyota Corolla. Total cost of ownership, including depreciation, taxes and fees, financing, fuel, insurance, maintenance, repairs, tax credit, which is 0. Total cost of ownership of that car over 5 years, Edmunds calculates at $25,528. And this means that you bought it, you've used it for 5 years and sold it again. And that's the bill you were left with after 5 years. And for the BMW, they give us $45,630 to buy, use and sell that car. The difference here is not going to be in all categories. So certainly between that one and that one. The financing cost is going to be approximately the same. Maybe the insurance is approximately the same. What you're going to save on fuel, I know tomorrow. So the lifetime, the 5-year life fuel cost of that BMW, they're calculating 7,941. So if you, with the Model 3 at approximately, let's say, 290 watt-hours per mile, is probably going to come in at maybe just a little over $2,100 over 5 years. if you pay 12 cents per kilowatt hour for every kilowatt hour. And I know in Germany sometimes those prices are higher, and that's wrong. It shouldn't be that way. What I calculated here is the total cost of ownership of that would come in at about about $26,100 at 40%. Excuse me. So, keeping all of Edmund's figures the same for where they're obviously the same, and adjusting the ones where they're obviously different. The biggest one of all being the depreciation. If you counted the 40%, 40% depreciation, so 60% retained value after 5 years, you end up with a cost over 5 years like that, which is not very different from that. And this is before tax incentives. Before tax incentives, which obviously annihilate that figure. Now, the reason I put such a high number here for the residual value is because I don't think it's far wrong. I don't think it's a stretch, and the reason for that is that the 3 Series, the Model 3, is going to have a very low running cost for the second user. And after 5 years, you'd expect 75,000 miles to have been consumed, of a possible million on that vehicle, not 300,000. And also, because of the short supply of the vehicle to begin with, there's probably huge residual second user market demand for that car. But you could effectively take a risk on that. If you say it's going to drop to 50% or 40%, you can take a view on it. But if that's anything like realistic, this is a horrible car. This is a really horrible car. Nobody really buys this car. No, they don't. To have basic comforts as a modern car, you take that and you upgrade it to $25,000. So you have reasonable seats and, stuff like, I'm about to say intermittent windscreen wipers, but that's probably not true. This is an extremely, extremely basic car. This is a third world standard car at that price. And that's nothing like the average selling price of that car in an acceptable format. And this one, in that price, that kind of a cost over 5 years. If you really want to be really unkind, put another $10,000 on it. We've been through the value comparison with the BMW, so you get to keep $10,000 over 5 years
for a better car.
For a better car, a really better car, unless you happen to really want to be on the autobahn, or you're a travelling salesperson and someone else is paying the gas bill. That's it. That's it. That's the end of the world when it comes to the internal combustion engine. And it's only the start. That's only the start. There's nothing you can do about economics. Because ultimately, economics drive the government that makes the rules. So there's no way out. If somebody, in fact, trying to ban probably 1 million consumers from buying that vehicle, which is actually the only strategic option that the internal combustion engine industry has got left in Germany or America or anywhere else, is to lobby a government to ban Tesla's salesmen. That's it. That's the only option. There's no other way of putting that genie back in the bottle. That wouldn't put it back in the bottle either. Because that would be 1 million people enraged by corruption in the government. Because consumers want to buy things for better value for money. obviously. Why wouldn't they? You can't tell consumers to pay more to help somebody's industry, especially one that's been given $50 million a few years ago just to stay in business by the same taxpayer. Can't do it. So this is the start of a very precipitous end for a very, very large industry, and it's not new. This is exactly what they did to coal and steam engines. Exactly the same thing. It's not different. All the same thing. And especially, it's interesting to think about this, because technologies don't die because the upfront cost of the new technology is lower. I mean, this goes back to the invention of the wheel. You know, if you have two sticks of wood and you put your sheepskin on it with something in it and you drag it along the ground, that's a very, very cheap tool for dragging things along the ground, but it takes a lot of work to do it. So a more expensive wheel allows you to do that much easier, with much less effort. You need 2 horses to drag a cart instead of 5, 6. So it's the running costs that kill old technologies. It's not the upfront cost. No one really has a problem buying a house as long as the heating bill isn't insane. You know, you buy an expensive house, you know the value's still there, you sell the expensive house later, hopefully it makes a bit. So if you look at the competition between the Model T Ford and the horse, the running costs of horses, the average horse is obviously a lot cheaper, even then, a lot cheaper than buying a Model T Ford. But people abandon all of their expenses on horses to buy a Model T Ford. A bit for the horse in your driveway, but an awful lot for stable hands to manually maintain that horse once a day. The cost or the usage of land, disreputable horse dealers, it's nothing new.
Goes with car dealers as well.
Yeah, I know, but it's no different. We've done it all before. It's just like, you know. And inns, the charging of a horse in a highway is absolutely ridiculous. You have, it takes ages. You have to pay a lot of people a lot of money to stable your horse and feed it, maybe reshoe it. And if you really want to pay some money, you can use it like a horse swap station. You just get another horse and carry on, if you want fast charging of a horse. So you have massive land, massive labour, lots and lots of money going to food and maintenance, so basically fuel and maintenance for a horse. Instead of which, you could have more asset value of a Model T Ford in your driveway. You have more asset value so you own more stuff, and you spend an awful lot less on maintenance and hassle, maintenance and fuel for getting the car to move. And you get some special advantages that the horse can't give you, like you can just stay out of the rain and drive, and much safer, interesting, much safer than falling off a horse to drive a car. And the other thing that killed the horse was tailpipe emissions. Have you ever seen a production car with a tail? I think they exist in production, but some cars exist in Disney vehicles or something. But a production car does not have something with hair on it sticking out of the back. It really doesn't. But it also has a tailpipe. Why is that? Why a tailpipe on a car? Because what we had with horses was biomass emissions. We had streets full of noxious semi-solid material lying visibly in the streets, which was not civilized. And people started to rebel against the idea of having the city streets full of horse manure. Emissions problem with the horse. And the tailpipe of noxious, semi-visible, gaseous waste, and we're talking about megatons of biomass waste, It's in trade for gigatons of gaseous, semi-visible noxious waste. It's not a victory condition yet because we still have a tailpipe. And we can argue long and short tailpipes, but we have a tailpipe on these cars which is causing enormous problems for people, especially for most people, and most people live in cities, where the solution is absolutely completely ridiculous. The streets are crowded and the air is toxic. Nobody would design that deliberately to do that. That evolved to be the way it is. It's not a designed solution. And now we have distaste, of course, for emissions from. We have distaste for emissions from internal combustion engine vehicles. It's really quite significant. And one of the things I think the internal combustion engine industry gets really confused about is the concept of consumer demand. What we actually have is no consumer choice. So if somebody buys 1.3 million Corollas, if people buy, they assume there is demand for 1.3 million Corollas. But it's possibly the case that there's almost no demand for it, given any other real choice. And there has never ever been, until now, another real choice. Never been one. It's not demand, it's entrapment. At all. I don't think anybody really actually chooses to pollute the atmosphere and pay for it as the main reason for buying a car. I believe there are a few, but it's very few. It's not the reason for buying a car. And I think I think they are deluded to imagine that the percentage of the market that they're able to obtain is actually representing demand rather than no choice. There's never been a choice before, but there is now. And these sort of numbers that we're seeing now of 325,000 accumulated intent to buy in a week, it probably extends to real numbers over the space of 1.5 to 2 years before that production starts. It's probably comparable to like the 1.3 million for that. And there are different reasons not to reserve such a car. For example, you're not ready to think about buying a car because there's nothing wrong with your old one yet. So the closeness to production is actually a factor in it. And this is also how technology disruptions evolve. The first, or tech adoptions evolve. First of all, the only thing that really matters is the performance you get for the price. So we can easily look at that down and say performance for price. Well, performance for price gets better over here with new technology. Once markets start to get saturated, then diversification becomes interesting. And when they get really saturated, then convenience of the ability to buy the car when you feel like it, rather than sit in a waiting line, it starts to get to be the competitive metric. So we're right at the sunset end of internal combustion technology, where overproduction is waiting for us to see if we might be interested. Whereas with a new technology, there's almost no choice of what you can buy. You can either have that or something else, lots of something else, or that one. So you have a concentrated queue for the EV. But there's a relatively predictable pattern how that will go out after that. And this is not about Tesla; it's about technology.
And
would you like a break?
In combination with you just sent me the chart from Google, right? Or was it somebody else? The Google search chart for Tesla.
No.
Somebody else. Okay.
No, well, I've seen that chart, and it looks like the.
Did you send it to me?
It looks.
Somebody sent it to me. Yeah. So
but it looks like the peeling curve.
You have the search bars for like BMW, Audi, etc. And you had the search bars, monthly search traffic for Tesla was like this, and then in the last month went like this.
Yeah.
And someone just sent me this chart this morning.
Yeah,
Or last night.
I've seen another chart like that.
car, yes. Looks very similar to another chart.
That's honestly, that's frightening.
Yeah.
Usually the peak every year is in May, and this was going into 403, 404, 405, 406 before the peak. So this is the most significant jump in annual atmospheric compensation, I think. Certainly, as long as I have looked at the subject, and that's quite a long time. So it looks like it might basically go up 7 or 8 points in a year, and that might be spread over 10 years. Maybe it averages out again, but it doesn't look good. And it's actually reasonably likely as well, because with what's happened with the low oil prices, it's not under demand, it's oversupply. It's really cheap to burn gasoline right now, and of course a lot of people take advantage of that. So the good news on the subject of change is not that it slowly gets better, is that it suddenly changes. It doesn't slowly get better, it'll slowly get worse, and then it will suddenly change. That's what happens. And there's a guy called Tony Sieber, I think it is. Is that the right name?
Yeah, Tony Sieber.
He does a presentation on disruption. He almost gets it, which is nice. He makes a good presentation. He has a lovely slide, and I don't have any, which is a picture of New York, central New York, in two separate Easter Day parades in New York. And one is all horses with one car in it. And the one 13 years later. 13 years later is all cars. No horses. These things don't go slowly. They really don't. And the idea of Toyota saying that it will slowly change its plans until 2050 to try to make 30% of its cars. No. The customers won't wait for that, and the capital will flow to startups faster than Toyota can handle it. It's delusional. It's not going to happen. It doesn't matter anyway what they say, because the same management won't be there, because it will be post-restructuring. Probably Toyota will survive, but not the same actual company run by the same people.